Okay, good morning students. So in the previous lecture we started instantaneous sender and we discussed how to locate the instantaneous sender of a 4-bar mechanism. Now the second basic mechanism, which is slider crank mechanism, this lecture will see how to locate the instantaneous senders for a slider crank mechanism. So there will be a slight change from the 4-bar mechanism because here we have a slider. In the case we have only rotating or oscillating links. Here we have a sliding link, so there will be a slight change. Okay, now hope you know the basics of slider crank mechanism. So I am drawn suppose something diagram for slider crank, a single slider crank mechanism. As you can see here, we have a crank OA and connecting rod AB and a slider. Slider is constrained in that path shown, the motion of slider. Okay. Next is how many, first before locating the instantaneous sender, that is our objective. You should know what is the number of instantaneous senders for a slider crank mechanism. So what is the number of links for a slider crank mechanism? First link is fixed link. We have crank and connecting rod and slider, that is 1 2 3 4, that is 4 is your number. We have 4 links in slider crank mechanism, that you know already. Okay, so how many senders will be there? We will have 6 sender. We discussed in the previous class. That equation is n-1 into n by 2. So we have 6 sender. So you write down all the 6 senders first for understanding. This will be same. We have 1 2, 1 3, 1 4, 2 3, 2 4 and 3 4. Okay, please refer your book if you don't know the previous class. Then how will you locate it? Some senders can be located by direct inspection, that you can do. First, here you can see one is joined with the 2 at point O. Therefore sender 1 2 will be there. Clear, simple. Then 2 and 3 are joined at point A, so 2 3 will be there. Now 3 and 4 are joined at B. B is a point where the connecting rod is connected to the slider. Okay, so 3 is connecting rod and 4 represents slider. Okay, remember 1 2 3 and 4 representing links, OA BC representing points. So B is at that point, so there, that is connection point of 3 and 4. It will be I3 4. Clear. So next is we have what we have to locate is I14. I14 means it is the sender between 1 and 4. What is 1? 1 is a fixed link and 4 is the slider. So where will we locate 1 4? That is a question. In the previous thing, what mechanism? 4-bar mechanism, 1 4 is located. I think the fixed point itself, because 4 is rotates about 1 at that point. Here this 4 is not rotating. Instead of 4 is sliding, so there will be a change. Okay, so if it is a rotation, if 4 is rotating, the instantaneous sender will be at this point only. Say for example, I am considering C as the point of contact. Just imagine, that's all, and it's not a single point of contact, but just imagine a center point or somewhere is C. Then we can say it will be the center, but in this case this is sliding motion, translation. So where will be the center? 1 is fixed link and 4 is sliding along the fixed link. Okay, so 1 4 means with respect to the fixed link, what is the center of 4 at the instant? So where will be the center? Just think, because it is a translation. Where we can consider translation as a rotation, or if translation can be considered as a rotation, where will be its center? That is a question. So you are so how to solve is, you have to consider this a rotation. If this is a rotation, the center will be, where will be the center? Center will be at infinity only, right? That is the answer. That is, since this is sliding motion, for a slider the center will be at infinity. So how will you represent it? You have to draw a vertical line. This is moving in horizontal direction, so you draw a perpendicular line to represent the center direction. Just draw the direction and with an arrowhead. So that is you are representing towards somewhere, that is towards infinity. Then you can write I14 at infinity. That is how you have to represent I14. Okay, clear. And remember, this line can be of any length. This is not representing your I14. This is only the direction. So you are putting the direction at you draw a line of any length and put the direction and write at there I14 at infinity. Clear? So these are 4 centers by direct inspection. Then we have 2 more centers. What are the centers? We should locate I13 and I24. So to locate I13, what I am telling is I am just telling with the reference to the previous lecture only. So you have to listen the previous lecture before listening this. Okay. Now to locate 1, 3, we should consider 2 combination of link 1 and 3. So link 1 and 3 combined with the 2. So we have one combination 1, 2, 3. You can put that in a box. Then another combination is 1, 4, 3. Okay, so these 2 combination can be considered to solve that. So when we consider combination 1, 2, 3, according to Kennedy theorem, we have 3 centers on the same straight line. Those centers are all different possibilities you write 1, 2 and 3. So we have 1, 2, 2, 3 and 1, 3. So you write 1, 2, 2, 3 and 1, 3 will be along the same straight line. Then next combination you take I1, 3, 4 or 1, 4, 3, where we can say 1, 4, 1, 3 and 4, 3. This will be on the same straight line. Now you join 1, 2 and 2, 3 similarly and extend. Similarly join I1, 4 and 3, 4 and extend. So this case we have 1, 2 and 2, 3. This is 1, 2, this is 2, 3. It is already joined because there is a link. So you extend that direction. Then next we have I14 and I34. So again here listen, I34 is this point B. What is I14? I14 is infinity only. Okay, I14 is infinity only. So you have to draw a line from I34 to infinity. That is this direction, the same thing only. Okay, this direction represent that line from I34 to infinity. So we are drawing it. If you don't have the sufficient length for your line, you have to extend it. So but this line the sufficient length, that's why okay. Otherwise you have to extend it to meet this line. So these both are meeting at some point, and that will be your I13. Similarly you locate 2, 4. To locate 2, 4, consider 2 combinations 1, 2, 4 and 2, 3, 4. When we consider 1, 2, 4, the centers are 1, 2, 1, 4 and 2, 4. Okay, 1, 2, 1, 4 and 2, 4. Then if you consider 2, 3, 4, centers are 2, 3, 3, 4 and 2, 4. So first you have to connect I12 and 14. So 124 will also be on the same straight line. Now again I12 is this point O. So I14 is at infinity. So how will you connect it? You have to draw a line from I12 to the infinity. That means say same line you have to draw from 1, 2 on the same direction. Okay, so you have to draw a line from 1, 2 to directly in the same direction to the infinity. Okay, so that is this line. That is, then again you note it at I14 at infinity. Okay, always you note it here, otherwise it will be not true, not be completed. Okay, then next combination is 2, 3, 4. So you have 2, 3, 3, 4 and 2, 4 on the same line. So 2, 3 and 3, 4 in the direction of connecting rod, you extend it, so it will meet at this point. So that will be your I24. Clear? This is the all instantaneous centers we located for cider crack mechanism. Okay. Now finally how to use it for velocity analysis. In case of a Seiderkang mechanism, input will be your crank velocity, and output will be slider velocity. In some cases, input will be slider velocity and output will be crank velocity. So these are the input and output, that's all. So if the crank velocity is the input, what you have to find is slider velocity. So how will you find? Using instantaneous center method. When we have crank velocity or details of crank velocity, will find the velocity at point A. Okay, velocity at point A will be equal to crank velocity, angular velocity omega into OA. That will be VA, or velocity of A, that you already done in relative velocity method, same step. So you got velocity of A now in your hand. Then what you have to find is slider velocity. So what will be slider velocity? Slider velocity will be VB. So VB means velocity of B with respect to fixed length. So what will be the velocity of B with respect to fixed length? Because B is a point where slider and connecting rod are connected. So the velocity of B with respect to the fixed point will be velocity of slider itself. Clear? Therefore, velocity of B you have to find. Then how will you find? You can you check point in your hand is VA, and what you have to find is VB. So A and B are associated with the link 3. Then you have to use I13. So I13 is here. So when you use I13, what equation you can write? VA divided by distance of A from I13, that is I13A, equal to VB divided by distance of B from I13, that is I13B. That is equal to angular velocity of 3 or angular velocity of AB. This is your expression or equation you can use for velocity analysis. Now VA you already calculated. I13A and I13B you have to measure from your diagram once you drawn. Then you will get VB. Okay, this you can skip. If angular velocity is not required, you can skip this to these points. Then you can only consider the first two sets VA. Then you will get VB. That's all. Okay, so you will that is how you will solve for a slider crank mechanism. So if you get VB, VB is your answer. VB is the slider velocity. Okay. Now problem this before that one more thing, if some students may have a doubt about B, how VB is slider velocity, again I will explain. B is actually a point in connecting rod also, so you may confuse with the VB, because in the okay, leave it, because B I will explain it. Remember, P is a point where we are connecting slider and connecting rod. So as the slider move, B will also move with the same velocity. Okay, there is no change. Therefore, velocity of B will be same as the slider velocity. But the change is we have some velocity called VAB or VBA. That is completely different. What is VBA or VAB? Well, VAB means velocity of A with respect to B, or VBA means velocity of B with respect to A. That is relative velocity that you can found in your relative velocity triangle. But VBA is different, that is relative velocity. VB is absolute velocity. Okay, that's all. Then which problem you have to do is, you already done problems on your problems with the relative velocity method. So you do the first problem on relative velocity method using instantaneous center method, and you confirm or check the answer with that thing. Okay, so thank you. This is a lecture on Seiderkang mechanism, and remember, previous lecture is there for your periodical exam, but this lecture is not there for your second periodical exam, or any lecture uploading after this will not be there for second periodical exam. Okay, but 4-bar mechanism, the previous lecture is there for your periodical. Thank you.